out here in a beautiful stand of corn that's at the V7 stage. It's a corn-on-corn field. We talk about how much nitrogen does it take to make a corn crop. University data would say it's 1.1 pounds of N to raise a bushel, and that includes growing this plant all the way up and then producing those kernels on the ear. So as we planted this field, we had 120 pounds of nitrogen applied with the planter. There were some in the starter on the seed and some on each side of the plant. We are now at side dress time, and this is our last chance to finish our nutrient program. So we came in here yesterday of a soil scan and we probed across this row. And so in a 30-inch row, we take 11 samples. And it showed that we have about 60 pounds left of the 120 applied. And that makes sense to me when you realize we had over 6 inches of rain up to this stage since planting on this farm. So no question, we have lost some in. So by doing the simple math, today is our last chance to finish this for that September harvest. So today we're going to be applying about 120 units. With the 60 that's remaining, that gives us 180. Now we're still 60 shy of the 240 needed. But don't forget, Mike and his buddies, the microbials, are going to create a lot of mineralization in here. And so nature's going to give us at least 60 pounds of nitrogen, or $30 an acre, free. So as we work this field today, and as we side dress nitrogen in here, we're going to be shooting at about 120 pounds. We talk about nitrogen and how it moves. So we have nitrogen in this slit in the center of this 30-inch row. And we know that nitrogen doesn't move horizontal. Take a look at this picture here of some ryegrass around our test plots. And what we had on here was 100 pounds of N with drip tape. And you can see the drip tape is 18 inches under the ground and 40 inches apart. That set of nitrogen stayed there all year in a vertical plane. You can see the yellow ryegrass in between the green, and you see the strips of green. It shows you that nitrogen moves up and down vertically of water, but does not like to move horizontal. This plant has been really busy in the last week here of setting and determining how many rows around is going to be on the ear, whether it's going to be 18 or 16. So when we talk about a 7-inch root ball and realizing the nitrogen's 15 inches away, that's going to be a long time before that plant sees this in. Wide drop positioning nitrogen next to the plant gives us quite an advantage. One of the real advantages of wide drop is it widens our window to apply nitrogen. So even though we're in V7 corn, we could easily go 2 to 3 more stages in growth. So if we would happen to get a rain this weekend and it would knock us out of side dressing, the wide drop lets us come in much larger corn. So not only do we have a timing advantage over a colder and the positioning, of course, where the nitrogen is placed, we now have more opportunity to get our side dressing done. To maximize the height of corn running with wide drop, we've extended this gauge wheel arm so that the tractor becomes a limiting factor. We talk about putting nitrogen at the sweet spot, which is right at the base of this plant. It doesn't take very much moisture to migrate that nitrogen down in the root system. Very simple math is, it's times 5, whatever your rainfall is. So if we had 1/10 of an inch of rain, that would equal a 1/2 inch in the root system. And it doesn't take very much. If I just add a little bit of water into this whirl, and you can see that it's going to quickly start to migrate down. As you see, it starts to migrate down around the base of that plant, and you can see that's exactly where the nitrogen itself would be. We're back in a field 7 days after the colder ran here for nitrogen side dress. And we can see that this colder mark is really starting to open up. I can take my jackknife and drop it right in there 2.5 inches deep, and it's almost 3/4 of an inch wide. So we've exposed the nitrogen to sunlight and to open air, and where we thought we had it 2.5 inches underground, it's just like being on top. If we would run a colder in a side dress application here at V6, and we've shown you fields where we could drop my jackknife in all the way from the top of the ground, it fell in an inch wide crack. If that crack had come down through here, instead of being wide dropped like this field was, if we'd have come in here for colder, this root would be snapped. In that case, this root would have been broke and we'd have broke the water line to this plant. So I like the profile that we had, even though it's been extremely hot and dry. We've been now almost 19 days without a rain, and we're in the mid-90s day after day, and you can see that this profile is staying intact, and we're keeping these roots all joined versus having a lot of cracks.
When we look at side dress corn, a lot of growers already have equipment sitting on their farm, potentially a side dress bar that's sitting there that would go unused if they went to another form of application on a post machine. But we're really seeing the value of growers moving away from the coulters on those bars that they potentially already own and putting 360 side dress on that. Let's just look at a few examples of different acres and different bars. So as you can see on the chart, we've got a 12-row machine, we've got a 16-row machine, and a 24-row machine, and you can see the break-even acres that we're talking about, and it's relatively insignificant versus the income and potential income that you can generate by being able to make that nitrogen more efficient by placement. So with just a 12-row machine doing 900 acres, you're looking at about a $13,000 difference to the grower after expenses. And as you work yourself down, a 24-row machine doing about 2,200 acres, you're looking at roughly about $33,000. So whether you're pulling a 12-row bar, a 16-row bar, or a 24-row bar, whatever your acres might be, you can utilize this chart to start thinking about what kind of an impact that just being able to place that nitrogen more efficiently for the corn plant to be able to uptake can generate on your farm. It's really all about efficiency and the ability for farmers applied nutrients to be able to get up in the plant to produce yield and to generate income for your farm.